I'm CK. A number of months ago I bought a Waihu hot air SMD soldering station, desoldering station. It was pretty good. You can look at that video. It's been very popular. So I was looking on Amazon for another one just to see what other alternatives there would be for me. And I found one for $39. It's from Daxiongmao. Again, out of China, and I apologize for not being able to pronounce the name correctly. And $39 for a hot air gun plus a soldering iron, temperature controlled theoretically. And let's take a look at it, see if it actually does the job and if you can get a good hot air rework station for $40 US. I hope you enjoy the video. Okay, so we'll see what's in the box, and I've made some changes to camera positions and lights, so maybe it'll be a little bit better. This is how it came from Amazon. As you can see, it's a fold-in that's not taped, so there's certainly a potential that something can fall out during shipment. And I apologize if you hear some noise. The crows are going really crazy in the strawberry fields behind my house. Okay, we've got a little tweezer, ESD coded, ESD 15, so that's probably okay. It's always good to get more tweezers. Power cord for US sockets, and it's got a really annoying multi-strand tie cable that we're just going to cut through because we don't have patience to do that. We have an instruction sheet. If not completely satisfied, let us know. When power turns on, things get hot. Use correctly. Don't touch the metal parts. Don't use flammable objects. Turn off the power when resting or after use. Always disconnect the power cord. Okay, so what we've got here, power at 60 watts for the solder side, and the SMD rework side, which is the hot air side, is 600 watts. That's not so bad. 110, 60 hertz, temperature range, 180 to 500 C. For soldering, that's 356 to 932 Fahrenheit. And on the hot air, it's 100 to 500 C, 212 to 932. Precision, plus or minus 5 C, plus or minus 20 C. Temperature calibration range, 99 units, don't care about that. Resistances, don't care about that. It's got a digital display, up and down key for setting your temperature. And then this one's got, this is good, it's got an air volume set to go up and down. Parameter of solder station, so yeah, it's all that. This is not a bad little, it's not a big piece of paper, but it seems to have everything we need. I've got all this stuff here to desolder, that's why that's all hanging around on the bench. Here's a stand, yet another stand. And a spung. Here we have, oh, they gave you a little set of soldering tips. That's nice. We've got some 0.8 millimeter solder wire. That's reasonably thick. It doesn't say whether it's leaded or lead free. And we've got some more 0.8. They're both the same size. Huh. Then we've got two different size nozzles for the air, and then the associated screws to clamp it down. Pretty compact unit, as you can tell. And here are the handles. This is the hot air handle. So it plugs in to the base, and all the heating and fan and so on are inside here, and we're going to put one of the solder nozzles on that, and it's got its own tie wrap, but it's a single So I'm not going to attack that with extreme prejudice. Here's the solder iron. Same thing, one tie wrap, and this is pretty standard. It's got a ceramic element that is exposed, so you have to be careful when you're changing tips. Wow, and it's kind of loose. I'm used to irons that have a little bit more, and it looks like they pre-tinned the iron for us, but they did a really lousy job. That's okay. Take this plastic bag and put it away. Oops. Bang my new camera and camera position. And here it looks like the base station. I hope I'm not getting my shoulder in the shots all the time. Let's see what we got. It's small. Again, this is a compact little unit. Another box. This is very light. This is barely, oops, one of the rubber feet just fell off. So we will put that back in. But this is barely 8 ounces. I'm going to get an actual weight on this. The buttons click well. So I assume, so this is up and down temperature for the soldering iron, up and down temperature for the heat, hot air, and this is the speed or volume of the hot air. We've got individual switches for each side. I don't know whether both sides can be on at the same time. We will find out. But what we will do is we plug this guy into here, like so, and it's got a good metal-to-metal locking ring, which I appreciate. Put this connector in for the hot air gun. So the iron will rest in there somewhat like so. And the hot air gun, not quite sure. I guess it'll fit like that. But let's get a nozzle. And I'm going to use a small nozzle because the parts I'm going to be desoldering are pretty small, and I want to see how I can concentrate the heat at a particular area. So we will put this screw through there, maybe, if I can get it right. Come on. Put the nut on it, and I have to get a screwdriver to snug this down. And that will slide over there like that, and we'll snug it down with this screwdriver, which I'll go get. I'll be back in a second. Actually, I'm going to go ahead and plug this all in, so I'll turn off the cameras and go get a scale to see how much the space station weighs and that kind of thing. Back in a flash. Okay, I've got my scale, and we'll put this on the scale. It is 255 grams. That's, oops, why did you go, I hit the wrong button. I hit the wrong button. And that is half a pound, 8.8 ounces. So this is really light, so it can't have any voltage regulation in it, I don't think, even though it has to have something, unless these buttons are just commands to the electronics in the handles themselves. So let me put these back in. I'm not going to lock them this time. I may take this base station apart later. I may not. Depends on how adventurous I want to be. Those go in snugly. I'm not doing the locking rings right now. We'll plug the power in, and nothing happens, which is good because both switches are off. Oh, by the way, there were 2 other nozzles 2 other diameter nozzles, so you get a total of 3 hot air nozzles, which is neat. So what I'm actually going to do, I'm not going to use the very, very narrowest one. I'm going to go to the middle because I don't want that much point heat. And they're easy to swap, obviously, if the device has been powered on recently. You want to make sure it cools all the way down. Okay, let's take the soldering side up. Fahrenheit 662 is where it's set to, which is fine with me. I generally solder at 625. That's hotter than other people do, but I like to be able to just get in and get out. I find that gives me less latent heat transferred to the component. So when the machine is powered off, press and hold the down key to change between Celsius and Fahrenheit. Okay. That's easy to do. I'm not going to change that. And this is continuing to heat up. Let me open one of these pieces of rolls of solder. Again, I'm not really interested in the soldering iron side of things, but we want to check it just for completeness. There's a little dot flashing there, so I don't know. Oh, this goes down 1 degree at a time. Let's put a little solder on it. Oh, it melts solder just fine. So we know that works. Now, next big test. Can you use both sides at once? On the Yihua, you are not able to. Let's see what happens here. Okay, that's coming up. May be able to hear the fan. Temperature is rapidly rising. We'll see what it defaults to. It defaults to 662 also. That's interesting. So you can have both sides active at the same time. And that's different than some of these others. I'm going to turn the soldering iron off though, because we don't need it. I believe you can hear the fan going. We can change the setting of the fan. It's oh, I see. So it's percentages. We're at 60%. There's 99% airflow. That's handy. I'll take it back down to 60, which they had it set at as a default. That seems like a good thing. Hit that button again, and we're at 662 on the temperature of the air. This cable is a little... I'm not sure this is silicone. I'll test that after I get the basic functionality out of the way. So the first thing I'm going to do, have a little circuit board here. Here's a big transistor that I'm going to try and desolder with these tweezers. Hopefully I'm not blocking the shot too badly. I got to stick my face in here. Not getting this one off. I'm going to try a different component first, a smaller one. I'll try, move this back a little bit. I'm going to try this diode. These tweezers are not very good. In fact, these tweezers are pretty much junky, so I'm not going to mess with them. Since I'm doing this diode, I'll go ahead and okay, I'm going to have to go get okay, so I put it back in the holder and it's blinking SLP, so it's going to sleep, which is good. The fan is still running. I think it's to cool itself off. which is fine. I'm going to go get another set of tweezers, a good one. I'm going to be really silly and put my hand in front, see if it's cooled off. Oh yeah, that's definitely cool. Still a little bit warm, but it's not at all uncomfortable. So now let me pull it out of the holster, and it's coming up to temperature again. 300, 600. Now we'll try this diode over here again. I'm not sure. This is not, again, you just saw me put my hand in front of it. I'm not sure we're getting the temperature I expect here. There we go. Pulled that one off relatively safely. I don't see any damage to the pad. Let's try something bigger. Let's try one of these electrolytic caps, and I'm going to use my needle nose to hold that. Gives me a little more distance so my hands aren't being burnt, which is not a problem with the device, it's a problem with where I'm putting my hands. So the nozzle is a little bit away. Never mind, I'll switch over to this capacitor. It's coming up. Yep. Oh no, it's not coming up. I pulled it off the, it came up, but I also pulled the traces off the board. Interesting. This is not working as well as the other, as the Yuha. I'm going to turn the temperature up. I'm going to go to max just to see what happens. That maxes out at 932, and I'm also going to turn the airflow rate up to about 98. Okay, it's at 800 and something. So let me get my tweezers again. There's my angle tweezers. And try to do this transistor right here. Oh, that came up very easily. I just needed to bump up the temperature and the flow rate, and there another one came up very easily. Let me take this, go back to this, well, I've got another electrolytic over here I can try. No, it's definitely, obviously with this much heat on it, oh, things are just falling right off the board. Yep. At a higher temperature rate, or higher temperature setting, it's doing just fine. I'm going to take it down to about 800 and see if I can still get removal, because I don't really want to run at 900. That's a little warm for some components, so we'll do 807 and go over here and do this. Ouch! Do this ouch! The board is very hot. The ground plane got very hot. Yeah, 800 with high flow. Things are coming off very easily. I'm going to put this one aside because the ground plane is heated up a lot. Now this is from Bose soundbar. Let me see. What do I want to pull off here? I want to try and pull off these chokes. Or this choke. Now I'm not getting that, but that could just be my technique. We'll take this cap off, because I think this is definitely lead-free solder. I'm not getting that one off. Just going to let it heat soak for a second. I'm going to go up temperature-wise again. There, that came off. Again, I'm not sure this temperature readout is accurate. I'm going to go back to this choke again, or inductor, whatever you want to call it. No, I'm not getting that one. Let me do this cap right here. Ouch! The other cap I just took off is still hot. Owie! Let's take this resistor off. Yep. So high flow, high temperature is what you're going to want to use on this one. Let me see. I hope you guys can see what I'm doing. I think you can, but I'm never quite sure. It's melting the hot glue, that's for sure. Okay, so that works on those surface mount components. Let's go over here, and here's a little through-hole project. I'm going to give that a little try. Not that I would typically use a hot air gun for through-hole, but if I got it up and running, I have it up and running. Let's see, I'm just going to look at it. Oh yeah, you can see it. Yeah, you can see it bubbling the residual flux. I'm going to put the end of these cheapy tweezers in here. Maybe I can pry that out. Oh yeah, that came out. See that? That came out very easily. So I'm going to go back. Wow, this is, but I will say, holding it here, it's warm to the touch. It's almost uncomfortably warm to hold it there. I have to hold it a little further back to actually not have my fingers be uncomfortably warm. I'm going to go back to this. Okay, here's, I got to step away for a second to get a different screwdriver, and I put the thing back in its case so it's in sleep mode again, and we can see if it cools off again. I need another screwdriver, and because I'm silly, I'll put my hand in front of the... Oh yeah, it cooled right down. It's still warm, but it's not burning the heck out of me. Now it's out. 400, 500, 600, 700. It's heated back up within, geez, less than 15 seconds. So I'm going to see if I can ease this transformer off the board. I don't know if I can or not. Surface mount IC right here. Let me rotate this around so I can grab it better. There, that came off pretty well. Didn't take too long. I feel like I heated it too much, but I'm not overly concerned about that. If it's a bad part, you're going to be throwing it away anyway. So that was through-hole, surface mount small components, and a IC. Works fine. I do want to try one more thing here, and I'm going to turn this off and turn the soldering iron back on. And this is going to run until it cools itself all the way off, which I appreciate. That's a very good feature. And let me check the soldering iron, see if it's up to soldering temperature. Huh. Feels like it's warming up, but it's not warming up very fast. Maybe it's because it's getting too much. Maybe it's the unit can't put up that much power. No, I think I'm going to have to I'm going to disconnect the, oh, just turned itself off. So now we should have enough power available to get the soldering iron heated up. Again, I did not buy this for the soldering iron, and I don't think you would either. You want to get a Weller or a Heiko or something for real quality soldering. Yeah, this barely heats up. Again, you notice that the fit of the iron over the ceramic heating element was pretty loose, and that's what's causing it not to be heating up very well, even though I've got it set to 600. However, what I did this for was simply because I want to check to see if this is high temp. Oh no. Oh, that's a no good. This is not high temperature silicon cabling, so when I touch the soldering iron to it, hopefully you can see I'm actually burning it where with the I'm sorry, I can't pronounce it. It's high temperature silicon, so it doesn't, I mean, I'm rubbing the solder off onto it, but the high temperature rubber does not get damaged. So that's a real, I'm sorry, that's a real serious strike against this unit, because you can accidentally set your iron down on here and potentially short the cable and cause an electric fire or something like that. That's no good. So while this is an interesting unit for $39 and the hot air side does seem to work okay, soldering iron does not, but the fact that these cables carrying the power to, that's 410, 600 watts in this case, going through that is not high temperature safe, is a real drawback. So for $39 US, if you just want to have a hot air gun and you're going to be careful, then yeah, you could use this. However, if you are going to be using this more than a little bit, I would definitely not get this because of the problems with the cable being low temperature rubber or nylon, or, so it melts whenever you touch the soldering iron to it. Now I think I am going to take the base apart, since I've decided I will not be using this again, because I've got the Huawei 948, which I also have a video up. I'll link in the description if I remember, which I probably won't. So let me get set up to take this apart. Okay, it's disconnected from power. The main leads are off it. I'll pop these feet off. Again, as you remember, one of them was already off when I took it out of the box. Now we'll get a screwdriver. Simple Phillips, nothing fancy, not Torx, not proprietary. I don't know if I'm going to have to take any of this other panel mounted stuff off. I don't know if I can. Oh yeah, I could unscrew this. We'll see if I have to. Let's see if I can do that without killing myself. Oh, that's not bad. They're not tight. I mean, I shouldn't be happy that they're not tight. They should have been. That was barely finger tight. Right. Oh, that came off pretty easily, didn't it? And inside, we've got power coming in. We've got circuit board here, which is, again, contains these two connectors that go out to the other devices, the handles, and the on-off switches. In here, looks like, I don't know if you can see this, looks like a little magnetic reed switch on the holster for the hot air gun to let it know that it's in there. These are not soldered, they're just regular slide-on connectors, so I'm going to try and pull them off. This is the main power in. It's being a pain. Oh no, it's being a real pain. But again, since I ain't going to use this ever again, I'll just nip these off. These are a little beefier. I should be able to break these off. Oh, I'm sorry, there's also some screws here. That won't help me. Oh, it might. I'll take the screws out just because. Where's my little green screwdriver? There it is. This is for holding the front panel where the controls for setting the temperature and flow are. Gosh, that... Okay. There is the output board, hot air, solder, the switches. On the back we've got a capacitor, got another capacitor, got a choke, voltage regulator, looks like BT136S. Looks like a class 1 capacitor, another cap here, and this is a, I don't know what that is, and then a grounding point. So that looks like it is filtering the power a little bit going out. And then on the main input board here, oh, I see why this is not coming out, because the hot glue that holds the magnet against the rest is being gluey. There we go. And here we have, I'm double checking that you're seeing what I'm seeing, digital display, the buttons, diodes, bunch of resistors, bunch of capacitors. I'm not seeing, we've got two ICs that I cannot read the part numbers on. I'm sorry, this one I can. It's an LM258. I don't know what that is. I may look it up and put it in the description later, but probably not. So here's the transformer, smoothing caps, good isolation, that's nice. Notation that screws go here. Here's two more ICs, three more ICs. These are microcontrollers of some type. Then another voltage regulator. And another, I think that's a fusible link for safety. And then over here, of course, we got a voltage regulator too, with the big heat sink on it. Though it has this kind of rubbery stuff instead of liquid heat transfer material. But, so that's it. Again, I tore it apart because I'm never going to use it, because I'm worried about overheating the cabling and potentially causing a fire. But if you're going to be very careful, for $40 US, this is workable. Again, $50 more, actually it's less than that now, maybe $20 more, $30 more, you can get the 948, which is a little bit safer. But I'm not going to rag on this all that much. It does work. The hot air side, the solder side, does not work very well. And that's the wrap up for this device. And I hope you enjoyed the video.